Good morning. Thanks for having me here. And it's really a pleasure here to be here in Berlin. What I'd like to take the time here today is really talk about our overall strategy, especially from a technology perspective, where we are focused on, where we're investing, where we see the future. And from that perspective, some of it I actually talked about to our investors about a couple of weeks ago back in Tokyo, where we have the world investors looking at why they should invest in Fujitsu, right? So the two, it talks about AI and quantum. I would say in a nutshell, if you look at our overall strategy, we are really, we put this out in the world about 5 years ago. These are the 5 key technologies we are going to focus on, which is AI sitting in the middle, the computing infrastructure to support AI, and networks, and then the security to secure that, which is really focused on AI, and then really looking at human sciences and combining that with technology, what I call converging technologies, right? So digital twins, industrial twins, that's what it is. But I would say, if you look at the bottom, AI with data security converging, we really kind of lump that as total part of our overall AI strategy. Yeah? And then you got computing with quantum and non-quantum both. And then the network side, which is really our DNA has been for a long time. And we started as a network company. And we branched out into computing company. By the way, this year is our 90th year, so it's a long history in technology space, probably one of the oldest companies. Now, when you talk about our Fujitsu AI strategy, the question that I ask myself, why should customers care about Fujitsu in AI space? Why are we even relevant? What's our value add? And I go back to our customers. Our customers are enterprises, manufacturing companies, retailers, government, defense, healthcare. This is mission-critical data. This is data where privacy is very important, security is very important. And you see that below the keyword, that's where we focus on sovereign AI. Right? If you're looking at general purpose AI or general purpose, whatever you want to do, like my wife does with ChatGPT, she doesn't care about Fujitsu. Right? I mean, all her needs are met by, she can log on to Google or whatever, query ChatGPT, and she's happy. I mean, why would she want a difficult thing like Fujitsu taking up the enterprise data, doing things? It's irrelevant to her. But enterprises that have a need for security, that have a need for specialized data models, that have a need for customizing these data models, tuning these data models, that's where we will add significant value. Think about it in a factory or in a plant that is manufacturing submarines. They are not going to put those submarine models on OpenAI or nuclear plants, right? Even with that, they want like 100 people accessing that. So for them, something like what we talked about, quantization, single bit, reducing the data to a single bit and storing that, right? Without really compromising on the accuracy of that. That is important. You can run this whole model on single GPU, 2 GPUs, right? Or running it at the edge. Looking at unstructured data. About 75% of data in an enterprise is unstructured. That doesn't even make its way to the LLMs. So, in defense or in government sector, social security, pension systems, this data where people don't want to put the data on the cloud, that's 99% or so. In some of the manufacturing industry, it's 75%. That is a very different thing than just querying ChatGPT and getting the answer. So that's where we add value. That's where I think is our differentiation. That's where customers want to work with us. We actually don't have our own large language model. We invested in a company called Cohere, which is a Canadian company that was started by Aidan Gomez, who's one of the original writers of the transformer models. We work very, very closely. We are own focus on technologies on security, on knowledge graphs, on RAG, and that's where we are focused on. So this is our roadmap, and we kind of put that out there. What are the five for next 5 years? And if you look at the top part is what we call the AI platform, and that has three components to it. One is the LLM side, which is we take the models and we have year by year what we come up with how we evolve these large language models. Second is the security side of it. We are heavily, as I mentioned, enterprises, heavily focused on security, and our goal obviously is zero hallucination, right? Obviously that's going to be very tough to achieve, but that's what we want to aim for. And then also the other part is agents, right? And this is an evolving field, agentic AI, right? That's where enterprises really, who are not PhDs or math or physics, they're going to be able to use AI, the agents, and able to combine those agents, multi-agents, where agents talk to each other without zero human intervention. So these kind of, the upper part then really is we've been doing that for a few years, and this is what we just laid this roadmap out there for next 5 years. This is our commitment out to the market. This is what we do, so people know where we're going. Okay. Now you see at the bottom is also what I call physical side of it, because what we see is a confluence of the physical devices and the upper side, the software stack. Because this is going to become more and more important at the edge. In factories, in robots. We don't plan to make our own robots, but we plan to work very closely with robotic manufacturers to build the brain of the robot, the sensory perception of the robot, the movement and the control, because we believe we got the fundamental technologies, the same needs that enterprise has. For example, if you're in defense and a soldier at the edge with edge devices, they're going to need very fast response, which means compute and networks and the software need to work very, very efficiently at the edge. So this is something that I think we believe is going to evolve a lot. This is an area we continue to invest in from a research perspective. And what I also think is, people often ask me, so when is this AI boom going to end? Forget about the stock market side of it, right? But I think from a technology perspective, we're just getting started. On a scale of 0 to 100, we are like at 1 or 2. That's where it is. This is think about how computing is going to evolve, and I'll talk about that today. Think about how some of the software side of it, LLMs are good. They have their limitations. What happens after LLMs, right? So that's really going to expand a lot more in the years to come. Next, I want to talk about computing to support AI. So we make CPUs. We are the only company, I believe, outside a US company that makes a CPU that is mission grade. So this FUJITSU-MONAKA is a successor to A64FX, which powered Fugaku, which was the top-ranking supercomputer for 5 years running. Now I think it's third or fourth. This Monaka is a 2-nanometer chip. It will be the world's first 2-nanometer server-based chip. It comes out next year. We are committed to ARM. We always have been. And this is an ARM-based chip, right? Highly power efficient. We benchmarked it. I think it's like twice as power efficient as a competitive chip from AMD or Intel at that point in time. It is focused on data centers, and it is focused on sovereign architecture. It's completely I would say the foundry is in Taiwan. That's the only foundry in the world that can make this today. There is no other foundry in the world that can do a 2-nanometer chip today. But other than that, it's completely made in Japan, and that's why this has a huge attraction for somebody who's considering sovereign architecture. People ask me, in fact, over a week ago, in Tokyo, I was asked, so where do you think this plays? And for us, defense, public sector, some parts of manufacturing, healthcare, same part as sovereign AI, right? We are not an American company. We are not a Chinese company. We are the alternative out there. That's how we position that. And it's actually resounding pretty well. Now, this is, we're working very, very closely with AMD, with NVIDIA, with Supermicro. Supermicro is committed to building servers based on Monaka as an ARM architecture. ARM is coming of age, right? We have SoftBank buy Ampere for $10 billion. I think if Monaka were a standalone company, it would probably be worth a lot more on that. Jensen, in his Computex speech in Taipei, he mentioned the collaboration with Fujitsu on FUJITSU-MONAKA, right, with NVLink. Same with the AMD. So this is something that we're heavily focused on. Fugaku Next, we announced 3 weeks ago with Ian Buck from NVIDIA was there, myself, and the chief of Riken. This will be the world's most powerful 20 exascale machine, AI machine, which the CPU will be from Fujitsu, and the GPU will be from NVIDIA. I'll talk about this briefly at the bottom. The focus targets that we are going after with Monaka are the data centers, because highly power efficient, and you're focused on enterprise data. And secondly is confidential computing. You talk about defense, the government sector, healthcare, same areas, right? Which is where you need sovereign computing, right? And this is the security is built at the hardware level. So even if if your virtual machine is hacked, you're still secure. I talked about Monaka X, which will power the next supercomputer. That's a 1.4 nanometer machine, a chip. So 1.4 nanometer will be the first of its kind. Again, the plan is on a single package. It'll be a 256-core machine chip, and on the single package, we will also have an NPU. NPU will take care of about 4 petaflops. You could do, and it'll be focused on inferencing and reasoning, right? And it can link with whatever is the PCI version at that time, PCI 7 Plus. It'll have ports for NVLink, and we also want to do scale out and scale up Ethernet on this. So this is really going to be the state of the art from a perspective of if people are interested in ARM-based compute. But focus on the whole goal, as we described 3 weeks ago, is to build the best AI CPU for this that can combine with any open GPU on this. And that's why NVIDIA, they wouldn't be interested otherwise if they didn't see the potential there. The other part of compute that we see a lot, and that's a big bet that we are making, is quantum, right? So we are heavily vested in quantum. And there's a lot of potential, right? I mean, things in material discovery, drug discovery, semiconductors. So think about, it takes, TSMC's perfected this to an art that they bring a chip or their whole production mechanism every year, every 2 years, they refine it. But they estimate their whole cycle time could go down by 50% if they could run these simulations much faster. Their drug discovery is the same thing. So there's a huge potential for quantum. And there's obviously the hybrid side of it, where quantum and HPC combine together, right? Because you wouldn't have, on the turn of a switch, you wouldn't go to quantum in one day. And we've been working on this for a long time, and I'll talk about this briefly. The quantum simulator, we offer the fastest simulator that's out there, a 40-bit quantum simulator that actually is being used by organizations today in material discovery, in banks, in medicine discovery today. Quantum devices, I'm going to talk about this shortly, but also quantum software. So we announced our roadmap about end of July, right? We committed that we will build a 250 logical qubit machine. That's going to be a hard task. It's better than what Google has got or IBM has got or anything else out there. And we're pretty confident we can do it. We have a 1,000-qubit machine coming out in about 6 months from now. We will build the control systems, which are equally difficult for the 10,000-qubit machine. We are going to build that in Japan with the startup, and the same with cooling systems. So this is going to be a pretty interesting journey, and the whole market is hotting up a lot, right? You see a lot of money going in, but again, in Japan, we are the only one that makes a quantum computer. I would say outside the U.S., very, very few. You got a couple of companies in Europe that are trying to do this. IQM is one of those, but I think we want to lead the pack in this area, and that's not just in the hardware, in the software as well, in applications, in error correction. We announced star architecture, which dramatically reduces the number of qubits that you need to build a fault-tolerant quantum computer. The other area that we look at outside superconducting is diamond spin. And we actually work with our friends in Delft in Holland on this technology. They're the world's leading university in this area. And here the quantum modules are connected by photonic links. And our vision is, at some point in time, now this is a concept, we'll see how it works. Superconducting is based on microwaves. You take those microwave qubits, you convert that into photons, you transport that, because photons transport that much better as a memory, and then you convert them back into microwaves. So we'll see how that goes. Diamond spin is much better in terms of the cooling requirements, right? You can do that at about 4 Kelvin. Superconducting is micro Kelvin, and that's hard as you scale that up. A couple of stories that I want to share. So we installed in Galicia, in Sesga, we installed the quantum machines there, with our, we built the overall system. We worked with a third-party quantum computer on this. Again, this is something that we are very, very vested in bringing this to Europe, not just Spain, but Germany, of course, and rest of Europe, the technologies that we built. And they've got a combination of both the quantum computer, the quantum gate computer, the HPC computer, and the digital annealer, as well as the quantum simulator. So they're combining these to do some very interesting research in Galicia, and we continue to invest there. Second is a story right here in Germany, where they used our digital annealing technology. And initially, it was, we were told the customers said they're looking at 600 parameters to optimize the problem. And we looked at it, and we said there are only 10 parameters that matter, not the 600, to drive the results. What that does is it really enables this bank to, optimizing 10 parameters is much easier than optimizing 600 parameters in terms of the compute that you need. And it's much more practical. So this really enables this bank to react much more quicker to the market conditions. And this is a good example of quantum. I would say the real stories today are quantum inspired, just because the superconducting quantum machines are not stable to do mission-critical applications today. But the applications can start working, right? A very interesting piece of work that we did, we released a research paper, and we'll be demoing this in Tokyo next week, is a robot. So we are basically looking at the robot, and the robot throws a baseball, and the angles of the maneuverability, if you feed that using traditional compute versus quantum compute, are very different. And you can see that, that the speed and accuracy converge much better with quantum entanglement, right? It's 40%, 43% error reduction with fewer corrections as compared to conventional methods. So it's just amazing the maneuverability, the angles at which the robot arm can maneuver with quantum versus non-quantum. So this is like a real example out there, right? As I mentioned, we put this very aggressive roadmap. We are committed to delivering 250 logical qubits with 1,000 logical qubit goal by 2035. We absolutely, I think this is one piece. As I mentioned, the other piece is HPC. We combine this together, and that will be the key infrastructure that will enable a lot of AI workloads going forward. This is where we're headed. I think what our goal is, where we are looking for is, we didn't talk much about networks today, but if you look at where compute and technology is headed, it's really going to converge at the end of the day with robots and humanoids, with the devices, with end devices. At the edge, you need networks, you need compute, and you need AI. And that's where we see that convergence happening. And I think this will be a dramatically different conversation 10 years from now. But the time to work on that is today. And hopefully we'll work with all of you as well together to deliver that. Thank you.